Hello, ladies and gentlemen, this is Mrs. Gallagher, and today we're going to discuss the real number system. So the real number system is divided into two categories. The first category we're going to talk about is rational numbers. So we're going to discuss rational numbers. And again, what are rational numbers? It's some decimals, and here's an example of two decimals, 0.5 and 0.3125, that terminate. They terminate. That means they end. They have a limited number of digits. Okay, again, they end. Other decimals, such as 0.3333 and 0.181818, have a repeating pattern of digits that never ends. Okay, so a rational number has either a terminating decimal or a repeating decimal. So terminating or repeating decimals are called rational numbers because they can be expressed as ratios of integers, better known as they're written as fractions. So anything that can be written as a fraction is considered a rational number. So let's look at some examples of repeating decimals and terminating decimals. Okay, so number one says 1/2. Well, 1/2 is equal to 0.5. Or you can say 0.5. Okay, that ends. It stops. So the next one, 5/16. Well, 5 divided by 16 gives us 0.3125. That also ends. Therefore, it is rational. The next one, -1/3. Okay, so 1 divided by 3 is 0.333, or 0.3 repeating. Notice it's a negative, so your answer is -0.333, and you could do the dots, or you can write -0.3 with the repeating sign. And then lastly is 2/11. Again, 2/11 is 0.181818. You could write it this way with the dots, because that means it keeps going, repeating. Or you can also say 0.18 with the repeating. Okay, so the first two, these end, they terminate, and here we have repeating. Okay, so let's look at some more examples of what rational numbers include. So rational numbers include three different categories: integers, whole numbers, and natural numbers. So we're going to define each. So an integer is a number with no fractional part that includes positive and negative numbers and 0. So again, an integer is a number with no fractional part. That means there's no fraction. And it includes positive numbers, negative numbers, and 0. So for example, -2. That's an integer. It's a negative number. -1, also an integer, negative number. 0 is included as an integer. And then we have positive numbers like 1 and 2. So basically it's any number with a negative, 0, or positive that does not have a fraction in it. The next rational number includes whole numbers. And a whole number is numbers that include positive numbers without a fraction and 0. So whole numbers are numbers that are positive without a fraction and 0. So for example, a whole number is 0. Okay, now I like to say whole numbers include 0. If you notice, there's an O in whole, so that's how you know 0 belongs with whole numbers. Put that 0 in the word whole. And then it also includes all positive numbers without a fraction. So 1, 2, 3, 4, any positive number that does not include a fraction. And then lastly, we're going to discuss is natural numbers. And natural numbers are positive numbers without a fraction. So natural numbers are positive numbers without a fraction. So the difference between a natural number and a whole number is natural numbers do not include 0. So for example, it would be just 1, 2, 3, 4, and then you're going to keep going. Okay, it does not include 0. Okay, so it does not include 0 in natural numbers. So let's look at some more natural number examples. Rational numbers include fractions. So an example of a fraction is something like 1/2 or 3/4, and also includes a fraction that has a negative in front of it. So like -2/5. Okay, those are some examples of fractions. They also include percents. So an example of a percent is 50%. We can say 100%. And again, it also includes a negative percent, like we'll say -4.5%. Okay, rational numbers also include decimals. Now these are decimals that we discussed earlier, that end or repeat. So for example, 1.6, it terminates, it ends. Anything that repeats, so for example, 4.12, and the 1, 2 is repeating. And also don't forget a negative decimal, so like -8.9054. Now we have a couple decimals there, but it ends. And lastly, rational numbers include perfect squares. So a perfect square is a product of a rational number multiplied by itself. So an example of a perfect square is the square root of 4. Why? Because the square root of 4 is equal to 2. Because 2 times 2 equals 4. Another example is the square root of 9. Why? Because the square root of 9 is equal to 3. 3 times 3 equals 9. And we'll do one more example of a perfect square, like the square root of 100. And the square root of 100 is equal to 10, because 10 times 10 equals 100. So these are some examples of rational numbers. Let's look at our next category of real numbers. We're going to scroll down. And the next category is called an irrational number. So an irrational number, this is our next category right here. An irrational number is any real number that cannot be expressed as a ratio of integers. So what exactly does that mean? It means that an irrational number cannot be represented as a simple fraction. It cannot be represented as a simple fraction. Irrational numbers are those real numbers that cannot be represented as a terminating or repeating decimal. So we discussed this before, and an irrational is the opposite of a rational. It cannot be represented as a terminating or repeating decimal. What I like to say is these numbers keep going and going and going. They're annoying to look at. They're irrational. So some examples of an irrational number is pi. Okay, pi, when you put that in your calculator, it's a number that keeps going and going and going. So anything with pi, if you have something like 3 pi or something like 2 pi divided by 4, these are all going to be irrational numbers. Another example of an irrational number is not a perfect square. So like the square root of 2, it keeps going and going and going after you put in your calculator. The square root of 71. These are not perfect squares, and it keeps going and going in your calculator. And a last example of an irrational number is anything with a pattern. So for example, 0.10, 110, 1110, etc. This is a pattern. Okay, it's not ending, it's not terminating. So your key here is anything that's not a perfect square or with pi or with a pattern. So you're looking for any number. An irrational number is any number that is not a perfect square, that has pi, and is with a pattern. And those are your irrational numbers. They keep going and going and going. They're irrational. So now let's look at our real number system chart. Okay, so here we have the real number system. And we're going to scroll down a little bit. So let's start in the center with natural numbers. Natural numbers we discussed, they are positive numbers. So anything like 1, 2, and we'll say 17. Next are whole numbers. And whole numbers include positive numbers plus 0. So we have 0, 1, 2, and once again, 17. Our next category is integers. And remember, integers include positive, 0, and negative numbers. So we have something like -2 and -1. But it also includes 0, positive numbers like 1, 2, and 17. And then lastly, we have rational numbers. And that's basically everything we discussed. Rational numbers we talked about include a fraction, such as 1/2. They include percents, such as 25%. They include decimals that end, and decimals that repeat, like 1.6, and we'll say 1.7 repeating. They also include perfect squares, like the square root of 16. That equals 4. It also includes your integers, like -1. It includes 0. And it includes positive integers like 1 and 2. So, with that being said, let's look at the 2 bullets below. Why is it important? Well, a natural number is also, let's look back at our chart. Notice that we have 1 in natural, 1 in whole, 1 in integer, and 1 in rational. So if it starts at a natural number, it's going to include everything above. So it's also a whole, integer, and rational number. So we're including everything if it starts at a natural number. It's going to be all of the above. Now a whole number, and if we look at the chart, here's your whole number, and you notice a whole number is 0 and your positive numbers. Well then, you have a whole number here at 0, it's also going to be an integer, and it's also going to be a rational number. So a whole number is an integer and rational. So a whole number is an integer and rational. So now let's look at the right side where it says irrational. And irrational and rational will never be in the same category. Irrational is its own separate. So numbers that are irrational we just discussed, it's anything with pi, not a perfect square like the square root of 19, and anything with a pattern. For example, 1.011, 0.00111, and we have decimals. It means it keeps going and going and going. So now let's look at our examples below right here. It says, name all the sets of numbers to which each real number belongs. And number 1 says -8. So you say to yourself, where does -8 start? Okay, well, -8 starts with the integers. Here's where your negative numbers belong. So as an integer, it's everything above. So it's going to be an integer and a rational. So it's integer and rational. Let's look at number 2, the square root of 46. Square root of 46 is not a perfect square. So that's going to be a long, ugly number, which is irrational. So that's irrational. Let's look at number 3. Number 3 is 22. Well, where does 22 start? Well, all of our positive numbers start in natural. So we discussed this before. If it's natural, it's everything above. It's going to be a natural, whole, integer, and rational. Let's look at number 4, 3/5. Where does 3/5 start? Well, all your fractions start right here in the rational category. So a fraction is just going to be rational. It's just rational. Number 5, -2.71 repeating. Okay, well, where do decimals go that are repeating? Again, they're right here, and that category is rational. So it's just a rational number. And now let's look at number 6. Number 6 is 0. And where does 0 start? Well, 0 is a whole number. So again, it's everything above. It's a whole, integer, and rational. So it's a whole, integer, and rational. So now what I would like you to do is the you try section below. So please do the you try section, numbers 1 through 6. and we will discuss it in class. Thank you.